The language of algebra. Algebra has several words that are new that we need to be aware of. Variables are letters that are used to represent a value that can change or vary. For example, t in the expression 2t plus 3 is a variable. Coefficients are the number by which a variable is multiplied, or the number in front of the variable. For example, the number 2 in the expression 2t plus 3. Look right here. Terms are numbers, variables, or the product of a number and a variable. For example, the number positive 3 or 2t are both terms in that polynomial expression. Which leads us to what is a polynomial. And a polynomial is an algebraic expression that is made up of terms separated by addition or subtraction. For example, negative 3ad, which doesn't have any addition or subtraction signs, that is considered to be one term. 15t plus 4ax has an addition sign between the 15t and the 4ax, so it is two terms. And the last one, 100 plus x cubed, there's a 100, there's an x, and then there's an x cubed, all separated by addition signs. That has three terms. There are several types of polynomials you should be aware of, and the first one is a monomial, and that's a polynomial with one term, just like we saw in this first example here, the negative 3ad. The number 100 by itself without addition or subtraction signs could be considered a monomial. 15t, if it didn't have any other terms with addition and subtraction signs, is also a monomial, as is y cubed. There are no addition or subtraction signs in a monomial. A binomial, I like to think of about a bicycle when I think of binomials. The prefix bi means two. So just like a bicycle has two wheels, a binomial is a polynomial with two terms. So you can see there's one term to the left of this addition or subtraction sign and one term to the right in 100 plus x. There's one term to the left of this subtraction sign and one term to the right in y cubed minus 3ad. One term to the left of the addition sign in 15t plus 5ax, and one term to the right of the addition sign. Polynomial has the prefix tri. A tricycle, three wheels, a trinomial, three terms. Again, one term before the addition sign, one term in between them, one term after the last addition sign. You can see there are three terms. Same with the last one. One term to the left of the subtraction, one to the right, and then there's an addition sign followed by a third term. Polynomials are typically written in descending order and alphabetically. Okay, so if I look at negative 3t cubed plus 4t squared minus 2t plus 1, I have to look, they all have letter t's, unless you talk about the constant term at the end, the plus 1. So we use all the terms with variables first, and we do the highest exponent first. And the exponent on t is just a 1, remember. Negative 2x to the 4 is the highest exponent, 3x cubed, 2x squared, and the x also has a 1. If they're in ascending order, we look at the exponents. The constant terms are first because they have no variables, and then t to the 1, t squared, t cubed, and in the second example, we have x with an exponent of 1, x with an exponent of 2, 3, and 4. So descending means the values are decreasing. Ascending means the exponents are increasing. Like terms. Like terms are terms that contain the same variable or variables raised to the same exponent. Negative 3x and 4x. We're only looking at the variable. They're both x's. They both have an exponent of positive 1. They are like terms. 15t squared and negative 4t squared. They both have a variable of t and an exponent of 2. Y cubed, 100y cubed, and negative y cubed. The variable is y. Both exponents are 3. Those are like terms. Unlike terms do not contain the same variable raised to the same exponent. Negative 3x and positive 4y, one's an x, one's a y. Different letters, not alike. 15 t squared and 4t, they both have a t, but the exponents are different. Y cubed and negative x, they both have an exponent of 3, but the letter is different. None of them are like terms. They are what are called unlike terms. Oops. Back up for a minute. If we want to evaluate the expression, negative 2x cubed plus 4x minus 3 for the following values of x, there are things we have to remember. When we evaluate expressions, we need to remember the operations. And we're putting in a value for the x. So I always start by putting brackets around the x in my original expression. And then I substitute in my values. So when x is negative 1, I put the negative 1 in to the bracket right there and right there. And then I have to take into consideration my good friend BEDMAS. Now my good friend BEDMAS tells me to do brackets first. When I look at those brackets, there is no mathematical work to be done in them. So I move on to exponents. And if I look at the negative 1 in the brackets with an exponent of 3, it tells me to cube it. So I'm dealing with that exponent first. And that gives me negative 1 to the exponent 3 means negative 1 multiplied by negative 1 multiplied by negative 1, which gives me the negative 1 on the next line. Gives me that value there. I can also do this multiplication in the same line because it's separated from the exponent by an addition sign. And positive 4 times negative 1 is in fact negative 4, which I'm going to do next. And the 3, I didn't touch the 3, so I just have to write it on the next line. Now if I look at the next line, I see negative 2 multiplied by negative 1. I see a subtract 4 and a subtract 3. Obviously, the multiplication has to happen first. And a negative multiplied by a negative gives me positive 2. And then I copy the negative 4 and negative 3 down. Now, addition and subtraction can happen in whatever order. When I look at it, I see that I've got a minus 4 and a minus 3. So I'm adding two integers with the same sign. That's easy. I just add them up and I keep the sign. So 4 and 3 is 7. They're both negative. The answer is negative 7. And I have positive 2 minus 5, which leaves me negative 5. Part B, we just change the value of x. We do exactly the same thing as we did before, brackets around the variable, and I'm going to put the 3 in to the brackets for x. And then my good friend BEDMAS tells me to do the exponent first, and because the 3 cubed is separated from 4 times 3 by addition, I can evaluate both of them at the same time. Remember, 3 to the exponent 3 is 3 times 3 times 3. And 3 times 3 times 3 is in fact 27. And 4 times 3 is 12. And now I have to multiply the 27 with the negative 2 because all I'm left with is the one multiplication and then addition and subtraction. And the multiplication has to come first. So negative 2 times 27 is negative 54 plus 12 minus 3. And I can group my negative numbers together. So I can just add the negatives. 54 and 3 is 57, and it was negative. And add the 12. Two integers with opposite signs means I subtract the digits. So I'm left with 45. And I take the sign from the larger digit, which is 57. Now to evaluate this on your calculator, you need to practice a bit. Negative 1 cubed, you will put the negative 1 and use the bracket buttons and press a button on your calculator that looks like a y to the x, or it looks like a little hat. Okay, that tells it you want to evaluate an exponent, or sorry, you want to evaluate a power, and this number that follows that button tells the calculator what the exponent is. Take the time to practice on your calculator and learn how to use it. It's important to know how to use your calculator because they all work differently. So practice working through these questions and evaluating these expressions step by step using your own calculator.